Is that supposed to say arc?
No, I just felt like being a pirate for a second. Arr, secant.
Real funny.
I thought it was kind of amusing. Not like a laugh out loud type of funny, but kind of chuckle on the inside type of funny.
I didn't get that from it.
All right, what do I do?
Find f prime of x. We want to use that rule we had. So arc secant is equal to d box over box.
Not yet.
Box.
What's the big picture, man? You're not.
We want to move our 5 down to in front of the arc secant.
Good. What rule is that?
Same rule.
You rewrite it, and then you can multiply by the derivative of the inside, which uses that formula. Derivative of the outside, then the inside. So derivative of the inside, what's the derivative of arc secant?
D box over the absolute value of box. Box squared minus box.
Box squared minus 1. Okay? So, what's our box?
X squared.
X minus x squared.
1 minus 2x. Absolute value of the box, x minus x squared, times the square root of box, which is x minus x squared, and minus 1.
Okay?
That's the derivative. Do we have to simplify?
No, you can't really do much here.
So what we're going to be doing is we're going to try to do the derivative of inverse trig, but you'll see here that this is more than just an inverse trig. We have to learn to recognize a big picture. Here we have two variables being divided. So the big picture is a quotient rule. And within that quotient rule, we have an inverse trig derivative, and we're going to have to use a chain rule for this bottom one. So let's see it in action. So again, the big picture, quotient rule, if you remember, is the bottom times the derivative of the top minus the derivative of the top times the bottom with no change over the bottom squared. Low to high minus high to low over low squared. That's how you learned it. However you learned it, f prime g, whatever floats your boat. Okay. Now that you know it's the quotient rule, let's go off to the side and calculate our derivatives of the top and the bottom. So I've taken the liberty to rewrite this as x to the a over b. Anytime you have a radical like that, the thing it's raised to becomes the top of your fraction, and that becomes the bottom. All right? So the radical power becomes the bottom. When we derive this, we get the following two things. If you remember, it's the derivative of your box, which is 2, over 1 plus the box squared, 2x squared. If you have a 4x squared right off the bat, that's fine. On this one, this is the chain rule, so you bring this down in front. You subtract 1. So minus 3 over 3 gives you 2 over 3. Notice this didn't change. And then you multiply by the derivative of the inside. The derivative of 1 is 0. Derivative of 4x squared is 8x. If you don't understand that, go back and review your chain rule. Now that we've done that, we plug it into the main formula for the quotient rule that we wrote up here. And when you do so, you get this following expression. V u prime minus v prime. And I took 5 times 8, got a 40 right there, over 3, x, and then times u with no change. Okay? All over the bottom squared. Now this looks like a horrendous mess, so we try to clean it up a little bit. You should notice that there's 2 like bases. Okay? This is implied to be over 1, so they're divided. So whenever you have 2 like bases divided, what do? You subtract their exponents. So it'll be 5/3 minus 1, which is 3/3, which gives you 2/3. So these two have combined into this one expression with these 2 exponents being subtracted. Didn't really do anything here. Now what you want to do is you want to factor out anything that's common or any fractions. So I see a 1/3 right there. I see 40 and a 2, so I can plug in a, so I can factor out a 2 out of the 2 and the 40, and then that 1/3 out of 1, a complex fraction, meaning a fraction within a fraction. So I factor out the 1/3 as well. And then I see that there's a 1 plus 4x squared to the 2/3 here, and a 1 plus 4x squared to the 2/3 there. That's nice. So I can factor it out. To figure out what's left behind, I take what I had originally, and I divide it by what I'm factoring out. In this case, you can see that this is the exact same thing as that. So when we divide them, we get a 1. And then we have this whole expression divided by this whole expression. So the 1 plus 4x squared to the 2/3 cancel. The 1/3 cancel. 40 divided by 2 is 20. The x, nothing happened to. Our tan, nothing happened to. All right? We're almost done. You should notice that we have 2 like bases right here. So we're going to do a subtraction one more time because they're divided. And when we do that, 2 like bases being divided, it's always the top exponent minus the bottom exponent. 2/3 minus 10/3. Negative 8/3 is our answer, so we plop it on the bottom and make it a positive 8/3. And that's our final answer. All right? So all that extra algebra, is it necessary? It all depends on your grader, wherever your grader is, but it never hurts to practice your algebra factoring out. You can be asked to find critical points and all that good stuff. Unlikely with something like this, but practicing nonetheless is always good. All right. So I hope I've cleared up some confusion enough for you to practice some problems. Check out the advanced video as well. And as always, practice, practice, practice. Thanks for watching. Have a great day.